Well, I was looking at the board after you guys left, and it is extremely chaotic. So right before you guys came in, I got some bad news, and I could not shake off being flustered. So I decided to record this, and I'll kind of go over my notes. And if you want another copy, I have extra copies up on my desk. Okay, so we said that x was the distance from the y-axis, and f of x was the distance from the x-axis. So if you look at this ordered pair, 2, 3, on the graph, you can see that this 3 units of the y is 3 units away from the x-axis. And the x of 2 is 2 units away from the y-axis. And I don't think I've ever really looked at that until I was going through this section, getting it ready. Okay, and then we have, and I don't know if I really made this clear, but y is equal to fx and fx is equal to y. You can switch them out, they're interchangeable anytime. Okay, domain and range. So with this first one, the domain is the width of the graph, the range is the depth of the graph. And we can use interval notation like we did in the last chapter for these as well. Anytime you have an infinity, it's going to be soft, which means you're going to use a parenthesis. And anytime you have a regular number, then it's going to be hard, and you can use a regular bracket. So on this example, number 1, the width is going to be to infinity because it's always going to be going up and over. And this is going to be going up and over this way. So it's negative infinity to positive infinity. We're going to read it from left to right. And so both of those will be parentheses. And then it has a hard spot that it starts. So it does not go below this. So with the depth of the graph, with the range, you're going to read it from bottom to top. So we start with negative 3 with the hard parenthesis, and then it's going to go to infinity, and that has a soft finish or a parenthesis on the end of that one also. Okay, for example 2, it starts right here and goes off this way in this direction infinitely. So if we're talking about the width, okay, it starts at negative 4, and that's a hard start, so it starts with a bracket, and then it goes to infinity, and so parenthesis. And then with the range, it also starts here at 0, and then it's going to go up forever. It's going this way, but it'll still be going up. So again, another infinity. And finally, the last one, this is the absolute value one. And this one is going in both directions. So negative infinity to positive infinity as far as how wide it is. And then as far as its depth, it starts right here. So that's going to be negative 1 with a bracket, and then going to infinity with the parenthesis at the end. I hope that makes a little bit more sense. Okay, let's flip this over. So if we're finding zeros and solutions and roots, all of those are the same thing. From a graph, we're going to see where it crosses the x-axis. So with this one, we have a parabola, and it crosses the x-axis at positive and negative 2. With this one, we have half a circle as defined by the radical equation. So it's going to cross or touch, be tangent to the x-axis at negative 3 and positive 3. We don't care where it goes through the y-axis. There's a y-intercept, but we don't care about that one. And then finally, this one right here, the rational equation goes through the x-axis at 3/2. And this one over here, our absolute value equation, goes through the x-axis at negative 4 and positive 4. Okay, if it's from an equation, we're going to set it equal to 0, and we're going to solve it for x. So, looking back at this example number 4, change your f of x to a 0, and then you can either factor it and set the factors equal to 0, or in this case, you can go ahead and move the 4 over, and x is equal to positive and negative 2. For example 5, I set the f of x equal to 0, and then I squared both sides to get rid of the radical, and then I moved both of these over so that my x squared was positive because I just don't like it that way, and then I set it up like I did the last one. and x is positive and negative 3, just like up here what we have in our graph. This one, the rational equation, I set it equal to 0, and then I multiplied both sides by x plus 5, getting rid of my fraction on this side, and I still have 0 on this side. I move the negative 3 over, solve for x, and I get x is equal to 3/2, just like up here on the graph. And lastly, the absolute value graph. I set my absolute value equation equal to 0. I added 4 to both sides. And then you have two cases. You have x is equal to 4, and then you have x is equal to negative 4. And I just went ahead and combined it because that was pretty much done. Okay, the last part of this is the increasing, decreasing minimums and maximums. Okay, and for these we can also use our interval notation. So from right here, this one right here is increasing infinitely from the left. Okay, so again it's going to be soft, negative infinity, up to it hits negative 2. Okay, so, and this negative 2, keep in mind the increasing, this is an interval over the x-axis. So the negative 2 has to do with what the width is at that point, not how high it is. So it's negative infinity to negative 2. Okay, then from negative 2 to positive 2, it's decreasing. But these are hard values, so they don't go off forever in either direction. So we're going to use brackets on both sides. And then from positive 2 to infinity, okay, and it's positive 2 to infinity because we're just talking about this interval, almost like this was a number line. It's going to be positive 2 to infinity, so bracket and soft parenthesis. Okay, and the last one. This is the last one that I put on the board. So it's increasing up to this point, then it's constant for a little bit, and then it's decreasing. And the increasing is from negative infinity to negative 1. Okay, so parenthesis and bracket. And then it's constant from negative 1 to positive 2. And those are going to be brackets because those are hard values. And then it's decreasing from 2 to infinity. And we have that right there. Maximums, it really doesn't have a maximum because this whole part is across here. Minimums, it also doesn't have any minimums. So we don't have any of those like bumps or whatever you want to call them in there. Over here on this one, we don't have any constants because it's always changing, either increasing or decreasing. Right here we have what's called an inflection point. Okay, it's going from concave out to concave in, but we don't really have to know about those too much yet. And then the maximum is the high point and the minimum is the low point. So hopefully that clears up a lot of whatever confusion I may have caused in class. I do apologize. So I will not be there tomorrow, but I will be back on Thursday. Tomorrow's Wednesday. Okay, talk to you later. Bye.